K-means clustering is a popular machine learning model that is used to cluster the data set into K number of clusters. It is same as shown here. The different colored balls are clustered into 3 groups based on the color as the common property. K-means clustering is an unsupervised machine learning model. Hence, it can be noted here that the model learns from the data set itself to cluster among themselves. Being unsupervised machine learning model, the data set used for clustering is unlabeled data set. That means, there is no class labels against each data point, and K is the number of clusters that the data set to be grouped. As a sensible AI/ML engineer, the value of K should be greater than 1. Let us understand the K-means clustering word by word. Very firstly, K is the number of clusters, and is required as an input. K should be greater than 1 always. That makes sense. Means, that is, the averaging method is used to generate new cluster centers. The data set is grouped into K number of clusters after the clustering is complete. There is some common property that is used to do clustering. Just like here, shown is the bin containing number of different colored balls. Here, clustering can be very well done using the color as the clustering property. And, that is why, here are 3 clusters as shown. Therefore, color is the clustering property here. Similarly, in K-means clustering model, Euclidean distance is the common property that is used to cluster the data set. Let us understand the Euclidean distance. Euclidean distance is the distance between 2 vectors of same length. A general expression for Euclidean distance is given here. One numerical example is also given here for understanding the Euclidean distance. Have a quick look at some important points about Euclidean distance. Euclidean distance is the straightest and shortest distance between the 2 vectors of same length. It is important to note here that the 2 vectors should be of same length. Euclidean distance is also called as Pythagorean distance, as the Pythagorean's theorem is the basis for Euclidean distance computation. Euclidean distance is always a positive and scalar quantity. More on Euclidean distance can be found on the below link. Now, it's high time to work out the K-means clustering using some numerical example. A data set containing X and Y columns is taken here for K-means clustering. The data set is represented in a graphical form using scatter plot as shown here. As can be seen here, there are 3 clusters marked as red, green, and blue colors. Let's call them as cluster C1, C2, and C3. Cluster 1 with center C1, cluster 2 with center C2, and cluster 3 with center C3. Now, let's achieve this clustering using the algorithmic steps in K-means clustering. Step number 1, take the value of K as number of clusters as an input to the algorithm. K should be greater than 1. Let's K is 3 here in this example. Step number 2. Randomly select any K number of cluster centers. As K is 3 here, take any 3 sets of X and Y as initial cluster centers. Say, the cluster 1 is C1 as 2 and 1, cluster 2 is C2 as 5 and 2, and cluster 3 is C3 as 7 and 8. Now, move on to step number 3. Put all the data set points in one column against all 3 initial cluster centers. C1 with 2 and 1 in ED1 column is shown here. C2 with 5 and 2 with ED2 is shown here. And C3 with 7 and 8 in ED3 column is shown here. Now, compute the square distance of each data point with each cluster center. Square distance is same as that of the Euclidean distance. Only square root is avoided. The square distance of data point 1 with cluster center 1 is shown here. Same way, the square distance of data point 1 with cluster center C2 and square distance of data point 1 with cluster center C3. So, we have square distances of data point 1 with each of the cluster center. In the same way, a complete set of square distance of each data point with each cluster center is compiled here. Step 3 is completed till now. Now in step 4, each data point is assigned a cluster number based on the minimum square distance. The data set point 1 has minimum square distance of 1 from cluster center C1. Therefore, it is assigned as cluster number 1. Same way, the data point 2 is also assigned cluster 1. And, data point 3 also in cluster number 1. Same treatment to data set point 4. And assigned to cluster number 2. Moving on to data set point 5 and assigned to cluster number 2. And data set point 6 also to cluster number 2. Data set point 7 deserves the same logic and assigned to cluster number 3. Using the same logic, data set point 8 is assigned as cluster number 3. And finally, data set point 9 is in cluster number 3. Here is the complete picture of each data point with their respective assigned clusters. Let's give them some color as red, green, and blue 1. Please note that, 2 1 being the C1, 5 2 as C2 and 7 8 as C3 initial cluster centers. Now, move on to step number 5, the crucial step. This is the mean step or averaging step. Take the mean of X coordinate of each data point in cluster 1. Similarly, take the mean of Y coordinate of each data point in cluster 1. Put the means, in the new cluster centers column. Same treatment for data set points in cluster number 2, and data set points in cluster number 3. Now, it can be observed here that, the cluster 1 with 2 and 1 has been changed to 1.33 and 1.33. Similarly, the cluster 2 with 5 and 2 has been changed to 5.33 and 1.66. And the same way, the cluster 3 with 7 and 8 has been changed to 7.33 and 7.33. This is the end of step number 5. In step 6, all the old and new cluster centers are compiled in a table as shown here. It's the convergence of centers check step. If all the old and new cluster centers are exactly same, or are within a desired threshold limit, then it's the state of convergence of cluster centers. If cluster centers are converged, that means, there was no movement of any of the data point from one cluster to another cluster in 2 consecutive epochs, and at this stage, one epoch is completed. An epoch is from step 3 to step 6. If cluster centers are not conserved, then, step 3 to step 6 are repeated with new cluster centers. It's all can be summarized as here. Step 1 is to take the value of k3 in the presented example. Step 2, randomly select k number of initial cluster centers. 2, 1, 5, 2, and 7 and 8 are here. In step 3, compute the square distance of each data point with cluster centers. Step 4, assign each data point to respective cluster number based on minimum square distance. In step 5, compute the means of cluster data points and generate new cluster centers. Here are the new cluster centers as computed in previous slides. Step 6, the check for convergence of cluster centers. If the cluster centers are converged, then, clustering is complete, or, take the new cluster centers and repeat from step 3 to step 6 as part of the next epoch. Now, at the end of epoch 1, this is the old and new cluster center scenario. As the cluster centers are not converged, therefore, take these new cluster centers and repeat from step 3 to 6 as part of the epoch 2. The same data points are taken in a table. With cluster center C1 as 1.33 Then, with cluster center C2 as 5.33 and, with cluster center C3 as 7.33 calculate the square distance of first data point with cluster center C1. Same way, the square distance of first data point with cluster center C2 and, the square distance of first data point with cluster center C3. Compile the complete table as presented here. Start assigning each data point to the respective cluster number based on the minimum square distance. As can be seen here, the data points at serial number 1, 2, and 3 are assigned to cluster number 1. Further, the data points at serial number 4, 5, and 6 are assigned to cluster number 2, and data points at serial number 7, 8, and 9 are assigned to cluster number 3. Now, perform the means step, means calculations for cluster number 1. Then, means calculations for cluster number 2. And, finally, means calculations for cluster number 3. Now, check for convergence step. If centers are converged, then clustering is complete. As can be seen here, that, the centers are same, that is, centers in previous epoch and the immediate next epoch are same. Hence, it can be stated here that the clustering is complete. And, here is the final clustering result. Here is a working Python code for k-means clustering using the same numerical data points. It's quiz time now. To submit your quiz response, please click on the Google form as marked below in the comment section. Type your response option against each question followed by comma and submit. All are multiple choice questions. Only one option is correct for any of the question. Select the proper option and put down in the Google form field. After submission of Google form, you should get the score analysis in few hours from Academy. Wish you a very good luck.